When adding a new ground-neutral bus to an existing electrical panel, a bonding jumper is crucial to ensure a reliable electrical connection between the new and old bus. The primary function of this bonding jumper is to provide a low-impedance path for fault current, thereby ensuring the proper operation of overcurrent protection devices like circuit breakers or fuses. It's essential to understand that the size of this bonding jumper is directly related to the service rating of the electrical panel. According to the 2002 National Electrical Code, or NEC, which serves as the benchmark for electrical safety in installations, the size of the bonding jumper must adhere to specific guidelines based on the service amperage. For services rated not over 1000 amps, the minimum size for the bonding jumper is American wire gauge, or AUG, number 8 copper. If the service is rated between 1001 amps and 2000 amps, the bonding jumper must be at least 3/0 AWG copper. In this particular scenario, the service entrance panel is rated at 125 amps. Because this rating falls well within the range of services not exceeding 1000 amps, the applicable NEC guideline dictates that the bonding jumper must be at least an AWG number 8 copper conductor. Therefore, the bonding jumper connecting the new bus to the old one must be an AWG number 8 copper wire. Using a smaller gauge wire could compromise the safety and effectiveness of the grounding system, potentially leading to hazardous conditions in the event of a fault. It is important to note that the main bonding jumper, or MBJ, plays a vital role in connecting the equipment grounding system to the grounded conductor, usually the neutral, at the service equipment. This connection ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. The bonding jumper being installed should have the same gauge as the main bonding jumper, which in this case is AWG number 8 copper. Before beginning any electrical work, it is crucial to de-energize the circuit or equipment. Failure to do so can result in serious injury or death. Always verify that the power is off using a reliable voltage tester before touching any wires or components. Wear appropriate personal protective equipment or PPE such as insulated gloves and safety glasses to further minimize the risk of electrical shock or arc flash. Consult the local electrical codes and regulations in addition to the NEC. Local codes may have additional requirements or restrictions that must be followed. It is always best to stay updated with the latest edition of the NEC and any applicable local amendments. If you are unsure about any aspect of the electrical work, it is always best to consult a qualified and licensed electrician. Working with electricity can be dangerous, and it is important to have the knowledge and experience necessary to do the job safely and correctly. Never attempt electrical work that you are not qualified to perform. When installing the bonding jumper, make sure to properly prepare the conductors by stripping the insulation to the appropriate length. Use a wire stripper to avoid damaging the conductor. Use appropriate connectors or terminals that are specifically designed for the wire size and application. Ensure that the connections are tight and secure to provide a low resistance path for fault current. Avoid using wire nuts for bonding jumpers, as they are not designed for this purpose and may not provide a reliable connection. Instead, use listed and labeled bonding connectors or terminals. Route the bonding jumper in a manner that minimizes the risk of physical damage. Avoid sharp bends or kinks in the wire, as this can reduce its current carrying capacity. Secure the bonding jumper to the panel using appropriate hardware, such as screws or clamps. Make sure that the hardware is compatible with the panel material and that it is properly tightened. After completing the installation, thoroughly inspect the bonding jumper and all connections to ensure that they are secure and properly installed. Use a torque wrench to tighten the connections to the manufacturer's specified torque values. This will help to ensure a reliable connection and prevent loosening over time. Once you have completed the installation and inspection, test the continuity of the bonding jumper using a multimeter. This will verify that there is a low resistance path between the new bus and the old bus. If the resistance is high, check the connections and make sure that they are properly tightened. Document the installation of the bonding jumper, including the wire size, type of connectors used, and the date of installation. Keep this documentation in a safe place for future reference. Regular maintenance of the grounding system is important to ensure its continued effectiveness. Periodically inspect the bonding jumper and all connections for signs of corrosion or damage. Tighten any loose connections and replace any damaged components. By following these guidelines, you can ensure that the bonding jumper is properly installed and that the grounding system is functioning correctly, providing a safe and reliable electrical system. It's also important to understand the overall purpose of grounding and bonding in electrical systems. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and energize the circuit. Bonding connects all metallic parts of the electrical system together, creating an equipotential plane that minimizes the risk of electric shock. Together, grounding and bonding provide a comprehensive safety system that protects people and property from electrical hazards. The equipment grounding conductor, or EG, is a critical component of the grounding system. The EGC provides a low impedance path for fault current to flow back to the source from non-current carrying metal parts of equipment. The EGC is typically a copper or aluminum wire that is run along with the circuit conductors. The size of the EGC is determined by the size of the overcurrent protection device protecting the circuit. The grounded conductor, or neutral, is another important component of the electrical system. The grounded conductor is typically a white or grey wire that is connected to the neutral point of the transformer or generator. The grounded conductor provides a return path for current to flow back to the source under normal operating conditions. The grounded conductor is also connected to the grounding electrode system at the service entrance. The grounding electrode system provides a connection to earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to flow back to the source. The grounding electrode system typically consists of one or more ground rods, ground plates, or metal underground water pipes. The size and type of grounding electrode system is determined by the local electrical codes and regulations. It's also important to understand the difference between grounding and bonding. Grounding is the connection of the electrical system to earth, while bonding is the connection of metallic parts of the electrical system together. Grounding provides a path for fault current to flow back to the source, while bonding creates an equipotential plane that minimizes the risk of electric shock. Both grounding and bonding are essential for a safe and reliable electrical system. In addition to the NEC, there are other standards and guidelines that may be applicable to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or OL. These standards provide additional guidance on topics such as power quality, surge protection, and equipment safety. It's important to be familiar with these standards and guidelines to ensure that electrical installations are safe and reliable. When working with electrical systems, it's always best to err on the side of caution. If you are unsure about any aspect of the work, consult a qualified and licensed electrician. Electrical work can be dangerous, and it's important to have the knowledge and experience necessary to do the job safely and correctly. The selection of appropriate tools and equipment is also critical for safe and effective electrical work. Use insulated tools that are specifically designed for electrical work. These tools are designed to protect you from electric shock. Use a reliable voltage tester to verify that circuits are de-energized before working on them. Use a torque wrench to tighten connections to the manufacturer's specified torque values. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Proper planning is essential for any electrical project. Before starting work, review the plans and specifications to ensure that you understand the scope of the project. Identify any potential hazards and take steps to mitigate them. Gather all of the necessary materials and tools before starting work. Follow a systematic approach to the work and double-check your work as you go. Good communication is essential for any electrical project, especially when working with others. Clearly communicate your plans and intentions to your coworkers. Use hand signals or other forms of communication to ensure that everyone understands what is happening. Be aware of your surroundings and watch out for other workers. A safe work environment is essential for preventing accidents and injuries. Keep the work area clean and organized. Remove any potential hazards, such as tripping hazards or flammable materials. Provide adequate lighting for the work area. Use proper ventilation to remove any fumes or dust. Regular training is essential for maintaining a safe and competent workforce. Provide employees with regular training on electrical safety, including lockout-tagout procedures, personal protective equipment, and first aid. Keep employees up to date on the latest codes and standards. Encourage employees to ask questions and report any safety concerns. Remember that electrical safety is everyone's responsibility. By following these guidelines, you can help to create a safe and reliable electrical system that protects people and property from electrical hazards.